Go. Hello. Hello, Mr. Ryan. Okay. We have suppose that you have enough money and then there's a price for each, the chocolate, for example. You want to buy a chocolate, yeah? You want to buy a chocolate. You want to buy and sell a chocolate. So let's say 1, 2. This is the price of the chocolate on the day, yeah? 10, 6, 8, 9. Okay. So let's say you have enough money, but the thing is that you can only sell it before. You can only sell it after you buy it. Okay, you cannot do the opposite. So you want to buy it first and then sell it, right? You can sell it after you buy it. So the profit, the profit. For example, today I buy the one chocolate using $1, and tomorrow I sell this chocolate for $5. How much money I can make? The profit.
What did you say? Okay.
So today I buy one chocolate using one coin or $1, £1, for example. Like tomorrow, I sell this chocolate for £5.
$4.
Okay, £4. Okay, so in this case,
$1.
Okay. So this is the prices for the chocolates on that day. This is the chocolate price, and then you can buy and sell once. So what's the maximum profit you can get?
110.
110. Well done, yeah. Can you get more, maybe? If I put a 19 here, what would you?
119.
Wow, well done. Okay, how about 7 here?
219.
Wow, so what's your approach? Yes, exactly. What's your approach? You can just see it directly, right, Ryan? Yeah, you can see it directly. What's your approach?
Brute forcing.
You can brute forcing so fast? Yeah, brute forcing. How do you brute force? How do you brute force?
Just minusing the number, not. Oh wait, this is how I work it out. So I just go through here and find
The smallest.
yeah, and then I find the biggest. Well, not really.
Okay. But look. But your algorithm may work, but there's an exception. That look, if this is 19, I put it here. I put it 19 here, and I put it, for example, 10. So you go look. This is the lowest, smallest,
Yes.
but this is the biggest. But the biggest comes before the smallest. You count, right? So what? If this is
Oh,
smallest, you can go.
And then, okay, so you find the smallest number.
Yeah. Okay.
And then
You look
I
for.
don't know.
You don't know. Almost quite close.
I get the biggest number after the smallest number. But if it's the
Yeah. So we want to find the biggest number after smallest.
I
So we'll
don't
keep
know.
checking, right?
But what if the smallest number is here?
Good point. Good question. Yeah. Okay. So we come to solve this later. Okay. But as you mentioned, we can solve this using brute forcing. How can we brute force? How can we brute force? Alright. How can we brute force?
We go through and
Ryan,
we
to
go
noise.
through like eat first. Oh, we can't.
So we try to brute forcing what? Brute forcing on the day we're going
Oh,
to
look, we
buy.
got 8 profit. That's pretty good, eh? And then it's like 2, 6. Still not good. Still not good. Still
Okay, so
not good.
can
8.
answer me. What's the approach to brute force? What are we trying to brute forcing?
Checking every possibility
Of what?
for profit. Max profit.
But how we trying to calculate the profit? I mean, we are trying to brute forcing that what? What are we trying to brute forcing here? Try the what?
We're trying to brute force.
Try the what? On which day we're going to buy and which day we're going to sell, right?
Yeah.
This is the thing we're going to try, okay? So if we try to buy this on this day, then we can try the sale on those days. If we try to buy it on this day, we can try the days here to sell, right? Ryan?
Yeah.
Yeah? Okay? So let's do this. Define max profit. No singing, please. Too noisy. Okay, the answer will be at the beginning 0, and n will be the days of the numbers. Yeah, the numbers prices. So now for what? Let's say buy, yeah, be in range what?
Range.
What? We can buy on any day, right? Yeah?
Yes.
And okay, then for sale, for S in range what? For each buy day, we can sell on what day?
We can sell
On what day? If we buy, sorry, let's not I. Let's B and S for B what? We buy on bed B plus 1, yeah, and up to N, right? Okay, now the profit. So answer equals, we want to keep the maximum profit answer. Okay, so how can we write this? What's the profit if we buy on day B and sell on day S? What's the profit if we buy on day B and sell on day S? Price what? Price S then and what? Plus or minus? Sorry? Plus or minus? Minus price what?
B.
Yeah. And return?
Answer.
Yeah. What's the term complexity? Come on.
1.
Come on. You see a 4. Why you still saying you're guessing?
1.
N square. What's the space complexity?
1.
Can you tell me what's O1? When I ask for term complexity, why you always say O1? What's O1? Sorry?
Because I like A1.
You like O1, okay. O(n) square, why is that? Because this is going to n, and for you have n possibilities, and for each choice, you have another n possibilities. Yeah, Eric, you got it? Yeah. So that's O(n) square, right? The space complexity O1 is constant because we are using only constant space. The answer 2 variables. Yeah, answer n, b, s. Okay.
Yes.
Okay. Can we do better?
Yes.
How? How can we do better? Look. Let's write this. Okay.
My first one.
3. Okay. So if we plot it.
But my way I just told you before.
Yeah. How?
Well, I don't know.
You told me what? What did you tell me before?
The thing, but it didn't really work.
Oh, you didn't really. Okay.
Yeah.
Look. How about let's plot the prices in. Can you sit there, please? In the graph. Okay. This is the day. And this is the price. Okay. Let's say the first day. 3. Okay. 3. This 3. 2. 10 probably here. Yeah. 6 probably here. Yeah. 8 probably here. 10 probably here. Okay. So if you plot it. Yeah. Okay. Yeah, you plot it. So what are we looking for? We want to look for look for the lowest peak. Lowest. This is called the lowest. Yeah. And the largest, the top. So that we want to look for the largest after the lowest, right?
But what if it's the lowest is at the end?
It doesn't matter still if it's the end. Look, if it's the end. Yeah, I'm just doing this if it is end. Okay. It doesn't matter. I'm just going to scan it from the left to the right. Okay. So the point is that we keep tracking of the minimum we have seen so far.
Yeah, but.
And then when we have the maximum, we can subtract it. No, not the maximum. We have a bigger number, then we can subtract the minimum we have seen so far. So look at this example. 3. Okay, let's say we have the minimum value, yeah. And then we have an answer, okay. And then you tell me if it's all right, okay. What's the minimum so far?
3.
Okay. And okay, then what's the minimum so far?
2.
So we get it. So we need to as well update the answer, right? Yeah. So what's the minimum so far? 3, and the answer will be the current number minus 3 is 0. Okay, because yeah, current number. And what's the minimum number?
Why? Okay. 2.
2, yeah. 2, yeah. Still, yeah. 2, and then still 0, right? Because the maximum is the current number is 2. 2 minus minimum is 0. What's the minimum so far?
2.
2. And then what's the current number?
10.
10 minus 2.
8.
This one max answer we want to find the maximum, and this minimum we want to find the minimum. Okay. Next one, what's the minimum number so far?
2.
What's the profit if we use the current list numbers minus the mean?
4.
4. Is it bigger than 8?
No.
And this, what's the minimum? Still so far 2, right? And 6. We're not updating, yeah? About 10. We're not updating this. 10 minus 2, 8 is the same. So what's the profit?
8.
Is that 8, yeah?
Mm-hmm.
Okay, got it?
Yes.
So the thing is that we keep tracking of the minimum value we have seen so far, and then we use the current value to subtract that, because we know in the past we have seen this minimum value, and then if we set it on the day, on current day, we can make a profit of a current number minus the mean number, alright? Yeah, so in this is one go, what's the time complexity? Oh, and we're done, yeah. Good job. So let's write this. Define max profit, prices. So that's n equals length. Actually, we don't need to define the n. Okay, let's say answer equals 0. The minimum value equals what? At the beginning, the minimum value will be what's the biggest number you can think of?
Infinity.
Max dot infinity. And now we go through,
Infinity
yeah?
plus 1.
For I in prices, we go through each prices. Now we want to find update the minimum value, yeah? So how can we update this? Mean value equals what? Alright? Mean and mean value of and then I, right? Right? Now we're updating the minimum value. And then now what's the profit if we set it on the on this day? What's the profit? Answer equals max answer and then what? Now I value minus what? Minus what?
Minus
What?
math to infinity.
Minus what?
Price.
Sorry?
Oh no.
Which one? Which one? This is
V.
mean V is the minimum value we have seen so far. Yeah? And I is the value, is the price of today. No. I is the price of today, and we need to minus
The price.
the minimum price we've seen, right?
Mean V.
Yeah, mean V.
That's what I said.
Okay, good job. And return.
Answer.
What's the time complexity?
O.
Oh, what? Go.
N.
Oh, why we going through at one time? Okay, what's the space complexity?
O. 1.
One. Okay.
That's what I was about to say.
Okay, so this is the we like we keep tracking of the minimum number and then we updating the profit, the max profit. Okay. Okay, so remember we talk about the Cartan algorithm, right? Remember? Yeah, Cartan thing. What does it mean?
Cartan is an algorithm for dynamic programming.
It's a rated dynamic programming to what does it try to do?
I forgot.
You forgot. We want to calculate the max subarray sum, right? Yeah, remember? Yeah. Let's do a little bit review, okay? So for example, like 3, 2, 1,
0.
10 minus 10 to 5. What's the maximum sum of the subarray? Subarray continuous, yeah? What's the maximum sum subarray? Which one? What's the sum? What's the maximum sum of the subarray?
3, 2, wait.
Come on.
2, 5.
2, 5. This is 7. This is 6. Yeah. You can't use this because you'll make the sum less. Right, Ryan?
Yeah.
Okay. Ryan? Okay, so look. So how can we do this? We use the DP array. Yeah? DPI. We talk about the subarray, the maximum subarray sum that ends the index I. And what does it equal? Equals max. This is the Cartan. Yeah, it's actually dynamic programming. DP I minus 1. Yeah. Yeah. And then if we choose the previous one, or if we don't choose the previous one, and then plus the current the numbers I, yeah, let's say ni. Okay. Okay. So yeah, make sense? Look. So DPI is that the maximum. Okay. Let me repeat. Maximum sum of subarray that ends at index I. Right? So DPI minus 1 is here. So what does it mean? I can choose to include the previous sum, right? And then I can add this, then I have a bigger sum. Or if I don't choose the previous sum, right? Because it could be too small, then I start with a subarray from the current position, right? Yeah? So how can we, this is the Kaban, the dynamic programming. How can we apply this to the problem of today? So first of all, it can be transformed. Okay, so look, let's say we have the price today, yeah, like A1, A2, A3, A4, A5. Okay, let's say this is the price for the day, for each day, and then we can have another array called B1, B2, B3, B4, B5. Okay, so what does it equal? So B1 is equal to 0, B2 equals to A2 minus A1. So it's the difference, yeah? Difference between these two numbers, yeah? So B3 equals A3 minus A2. B4 equals what?
A4 minus A3.
Yeah, well done. And B5 equals what?
A5 minus A4.
Okay, so this is the difference, yeah? For example, okay, 2, 0, 3, 5. Let's say this is A array, and what's B array? B array equals 0 and what? And what? What's this value?
0 and 2.
Minus 2 and then?
Minus 3.
3 minus 0, 3, and then 5 minus 3? 2, yeah?
2.
Okay. So how is these two related? So if I say, okay, so the lowest point is A2, and then the selling point is A5. So if we want to buy on the A2 and then sell on the A5, then we got the next profit. Right? Yeah? Correct?
Oh yeah.
So how can we relate these to each other? So if we added these B2, B3 plus B4 plus B5, right? Yeah. If we B3 plus B4 plus B5, what do we get? A3 minus A3 cancel out, yeah. A4 minus A4 cancel out, yeah. So what do we have? A5 minus A4, A2. A5 minus A2. You see? So this is exactly. So we are looking for, look, this is B3 plus B4 plus B5. Is this. And then what does it equal? It equals A5 minus A2. A5 minus A2. So this is the profit. So what does it mean? It means that we need to calculate the longest, the maximum sum of subarray, right? Yeah? And we already know use the Cartan algorithm, right? To solve this. So as long as we transform the original array to this, then we can calculate. It's the same thing as calculating the maximum sum of a subarray, right? Got it?
Yeah.
Are you with me? This is challenging, right? Mathematics challenge. You want a challenge, Ryan? You say you want a more challenge? Are you with me? Yeah? It's okay, you don't follow, but try to understand, okay? Okay, let me repeat again, okay? This is a bit tricky to understand, okay? The original array, the prices. If A2 is the lowest point, and A5 is the max, yeah? After this lowest point, and then profit we can make is A5 minus A2, right? Yeah? Example, yeah? So if we transform the A array to B array, B is the difference, contains the difference, yeah? Difference of the price of each day. Then look, what do we get? B3 equals A3 minus A2. B4 A4 minus A3. B5 A5 minus A4. If we add B3 plus B4 plus B5, what do we get? We cancel out the terms. So this will be equal to what? B3 plus B4 plus B5 equals A5 minus A2. right? This is the profit. So in other words, we are looking for the maximum sum of the subarray. Because look, this is the subarray of the B, right? This is the subarray of B. We want to find out the subarray in the B array. Right? Okay? Okay, let's write this. And we already know to use this Cartan algorithm, right? Cartan algorithm. The time complexity of Cartan algorithm is what?
O-N.
Okay. Define max profit. O(n), usually O(n) for the array is that we're going once. Right? That's O(n). That's what O(n) means. Ryan, do you get it? O(n) means that there's an array and we need to ask computer to travel, just to go once or two times, constant times. Even you go to the half, it's still O(n), right? Got it? Does it make sense, Eric?
Yeah.
So there are 10 elements. Let's say there are 10 elements. And your algorithm requires to visit each element once, like from 1 to 10, to sum, to make to compute the sum or get the average or whatever. It's O(n), right? Okay. Max profit. And let's say numbers. First of all, we need to prepare. Okay, let's say n equals length. This is the number of the elements in the array. And answer, let's say, at the beginning is 0, right? Right?
Yeah.
And what do we do? For I in range, we start from the first one, right? 1 to n. Right? And then what? We need to have another current, okay? Current equals 0. Current plus equals price nums, yeah? We want to find the difference. Nums I minus nums I minus 1, right? This is the B array, right? This is the B array. And then if current is smaller than 0, we set it to 0. But so now we can rewrite this. So do what? Current equals max. What? Max this plus current 0. Okay, and then we can have answer equals max answer current, right? And then return answer. Okay, so what's the space complexity if we still remember?
O.
What's the space? Are we using any additional space?
No.
No.
1.
O(1), yeah, O(1) constant. Look, answer. This is the answer with the maximum profit. This is current, right? We are looking for the maximum subarray, right? The subarray sum. So the current. This is the subarray of this is the B array, right? We calculate difference. And we add it. Yeah, this is the array. We calculate difference plus the current. We use the current value or we don't use it. Okay, we use the current value or we don't use it. Yeah? Okay. Yeah, Eric, does it make sense, Eric?
Yeah.
So which one do you think is better? All the three algorithms. The first one is brute forcing. The second one is use what? We remember the lowest point and then the highest point in the future, right? And this one is the transform the original array to another problem.
The Cardan.
Yeah, using the Cardan. So what's
Cardan.
you think Cardan is better? Eric, what do you think?
Cardan.
Why is that?
Because it's O(n).
It's both are O(n). The second one and the third one is both O(n). So which one? Why do you think it?
And O(1).
The time and space complexity for the second and the third solution is the same. Okay. Make sense?
Yeah.
Current plus the
I think.
yeah. Which one? Sorry. Okay. Any questions so far?
No.
Ryan, any questions? Any questions? If not, then bye bye. See you.
再见。
再见，来，Eric，来，拜拜。
拜。
拜。